Alright, let's get started with the 9.5 Hyperbolas worksheet. Why don't you start by getting out your packet, and we're going to go through the notes side of the Hyperbola worksheet. It would also be helpful if you had another color, maybe like a red pencil or something like that. Okay, so this is basically just copied word for word from your packet. The first one says find the length of each axis of this hyperbola. So this hyperbola is on the top of your worksheet. So for AB, that's going to be from here to here. So it looks like it's 2, 4, 6 on each side. So AB altogether is going to be 12. Okay, CD is from top to bottom. That's 4 up and 4 down. So 4 and 4 is 8. Alright, it says the center of the hyperbola is 0, 0. Find the distance from A to the origin. So from A to the origin, we said that was 6. Find the distance from C to the origin, we said that was 4. Okay. It says points A and B are the vertices of the hyperbola. Find the coordinates of these vertices. And so on hyperbolas, the vertices are just like the vertices of a parabola. It's where the hyperbola comes out, where that graph starts. So this vertex is going to be at negative 6, 0. And the other vertex is at 6, 0. Alright, it says points C and D are the covertices. So the covertices are the other parts of this box here, and we'll talk more about this box later. So the vertices are where the graph actually touches. The covertices are the other ones. So C is 0, 4. And D is 0, negative 4. Okay. So it tells us that the equation for this hyperbola is x squared over 36 minus y squared over 16 equals 1. The question on the sheet says, where do the 36 and 16 come from? Well, hopefully you've realized the 36 is how wide it is from the origin or from the center of that box out to one of the vertices in the x direction. So it's 6 squared, much like we had on ellipses, you square that bottom number. And then the y, this box is 4 up, and so this is 4 squared. So where do they come from? 36 is 6 squared. And 16 is the 4 squared. And the 6 and 4 come from the horizontal and vertical lengths and heights of the box. Okay, so on to the next part. It says if a hyperbola has vertices 3, 0 and negative 3, 0, and covertices 0, 5 and 0, negative 5, then its equation is, so let's graph this. 3, 0, 1, 2, 3, negative 3, 0, 0, 5, and 0, negative 5. So we're going to make this little box here. Hopefully yours is a little bit more rectangular than mine. And it says the vertices are 3, 0 and negative 3, 0. So what that means is that the hyperbola is going to be coming out of here and here. And then it's also going to be coming out of this vertex. Okay. So on the previous problem, the equation was, scroll down, was x squared over 36 minus y squared over 16 equals 1. So on this one, it's going to be x squared over 9 because the box is 3 wide. Oops, I'm sorry, just 9. It's 3 squared. Minus y squared over, and then this was 5 tall, so 25 equals 1. So that's going to be our equation for this hyperbola. Okay, and then just so you know, the co-vertices are here and here. Co-vertex and co-vertex. And this would be our vertex and our vertex. And we'll get into how to find the foci, or the focus, on the next video when we run through the next problem. Okay, if a hyperbola has vertices a0 and negative a0 and co-vertices 0b and 0 negative b, then its equation is, well, let's look at this one. This had 3, 0, negative 3, 0, and we put 3 squared on bottom. This was 0, 5, and 0, negative 5, so we put 5 squared on bottom. So it's going to be x squared over a squared minus y squared over b squared equals 1. Okay, so let's look at another one. This time, this hyperbola opens up and down instead of on the sides like the other one. Okay, so it says the hyperbola plotted at the right is centered at the origin with a vertical axis of 14 and a horizontal axis of 6. So the vertices are, remember the vertices are where the hyperbola comes out of. So it's going to be 0, 7. And 0, negative 7. Alright, it says the co-vertices, that would be E and G. Those are 3, 0, and 0, negative 3. I'm sorry, negative 3, 0. I said that wrong. So 3, 0, and negative 3, 0. Alright, so it says the equation for this hyperbola is y squared over 49 minus x squared over 9 equals 1. Okay, so very similar to the previous problem. But then what it says is, what's the difference between this equation and x squared over 9 minus y squared over 49 equals 1? Well, there's one glaringly obvious difference. This one, the y squared comes first, and this one, the x squared comes first. So, does it really matter? And the answer is yes, it really, really does matter. If it's a y squared first, then it's going to open up and down. If it's an x squared first, then it's going to open side to side. So if we had, I'll change to red here, if we were graphing this equation, which the only thing that changes is the x comes first and the y comes second, so it's x squared minus y squared, but the number under the x is still 9, the number under the y is still 49, so this box would not change at all. The x would still be 3 wide, and the y would still be 7 tall. What's going to happen, though, is this hyperbola is going to come out of E and G if we were to graph this one. Okay, and so this, if we were graphing this equation here, this red one, it would be a much wider set of parabolas. I don't know that they're technically parabolas, but it'd be a much wider set of parabolas because these blue lines are actually asymptote lines. And so this red one's going to eventually get close to that blue one, but never touch it. Where here, the asymptote lines make it a lot more narrow. Alright, so last part on this page. It says a hyperbola has two asymptotes, which I just talked about. The asymptotes can be found by drawing the lines that are diagonals on the box. So that's why we make this box. We're going to connect the opposite corners, and that's going to give us the asymptote line. So we have one asymptote line going this way with a negative slope, and the other asymptote line going this way with a positive slope. So the equations for those asymptotes are plus or minus b over ax. So y equals plus or minus b over ax. So this is in y equals mx plus b form. This is our slope. and it's plus 0 because our y-intercept is 0. Okay, so it asks determine the equations and label the asymptotes of the two graphs at the right. So let's find the asymptote lines here. Looks like our A, or our run, is going to be 3, and our rise is 7. So this line here is y equals 7/3 x. And then the other line is going to be y equals negative 7/3 x. So one of them is positive that fraction times x, and the other one's negative that fraction times x. So, simple enough, I think. Let's scroll down to the other one. It says determine the equations and label the asymptotes for this graph. So on this one, this was the first example, the one in the upper left of your paper. The asymptote line here, let's see, the rise is going to be up 4, and the run on this box we said was 6. So this asymptote line here is going to be y equals 4/6x. And then the other asymptote line has a negative slope, so it's going to be y equals -4/6x. Alright, so that's basically this note sheet. If you would like help with problems 3, 4, and 5, you can start the next videos. Otherwise, this is all we need to do for tonight, and we can start on the problems tomorrow.